Today's Cloudcast is sponsored by UpCloud. Is your website running slow? Supercharge your hosting performance by deploying on the world's fastest cloud infrastructure. UpCloud offers superior cloud servers with advanced scalability, instant backup snapshots, an easy-to-use control panel, a fully featured API, and a ton of integration options and management partners. Pricing starts at only $5 a month with enough performance options to host any website or app, all backed by 24/7 live in-house support. You can get started today with a free trial using the promo code CLOUDCAST at upcloud.com/signup. That's upcloud.com/signup with promo code CLOUDCAST and receive an extra $50 to get going. So remember, that's upcloud.com/signup, promo code CLOUDCAST.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast. It is good to be back with all of you this week. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hopefully everybody's doing okay. It seems like the weather is getting a little bit colder in various parts of, at least here in the United States, and that's kind of obvious for where we are in the winter season. I know we've seen some crazy snowstorms around the world in different parts up in Canada, a couple of feet up there and so forth. So hopefully everybody's staying warm and doing well. Before we jump into Cloud News of the Week, I wanted to do a quick, brief update on where we are with the Donut Run, the Krispy Kreme Challenge, the event that we use to raise some funds for the North Carolina Children's Hospital, kids and their families who are sick, have some very difficult situations in terms of their health, in terms of disease, things like cancer and some other really tough situations. And so we've been raising money for that. If you go to the show notes, there is a link every week. It just says Donut Run donations. If you click there, all donations, every bit of it, 100% of it goes to the North Carolina Children's Hospital. Just want to give a quick update. We are at about 70% of our goal. The race is the first weekend in February, so we've got a couple of weeks until that happens. But we're at about 70% of our goal. So our goal is about $3,500. We're right around $2,500. So thank you to everybody who's made a donation. And if by chance you feel generous, you feel like you want to help some kids and families in need, it would be greatly appreciated. So thank you very much. So let's get right to Cloud News of the Week. Couple of interesting announcements this week, couple of interesting kind of things going on, kind of a diverse set of stuff this week. The first one was Apple made an acquisition. They bought an AI startup called Xnor.ai, XNOR.ai, for around $200 million. Company was 30, 40 people. Developer of machine learning software models designed to work with applications for things on the edge. So trying to bring some AI models to the edge for lower power devices, the things that Apple does. So this is probably not something you will see as a feature, but it will probably become an embedded part of iOS or future devices from Apple. So that's sort of interesting. Second one around acquisition was Equinix. So the company that is extremely well known for being in the colo space, doing lots of work, interconnecting companies to the public cloud, things like that, acquired Packet. So Packet being a cloud provider who really focused on bare metal. So interesting to see those two things coming together, a little bit of consolidation in the colo and managed service space. Third was, it's interesting. We're always sort of looking forward. What are we doing? What's new? What's the next new device? Seeing a little bit of love for the legacy IBM systems. So we saw this week, Google made an announcement about offering access to P-Series systems. We had seen something similar from Microsoft back in the fall of 2019. So interesting to see those two things coming together. I think we may actually see some other news about some of the legacy or heritage, as we now like to call IBM platforms, and some new things coming to those as well. So keep an eye out for that. But interesting to see, companies realize that those systems aren't going away. They still run a lot of business, and maybe there is some interesting economics that can come out of essentially renting those in a more of a cloud type of model. So it'll be interesting to see when pricing for all that comes out. But interesting announcements from Google. And then finally, last thing in our Cloud News of the Week, I want to give a quick shout out to our friends over at TriggerMesh. Sebastian and Mark Hinkle, who, we've known for a long time from the cloud.com days, and Sebastian's been on a couple of times to talk about serverless. We had them come to talk about their activities around TriggerMesh when they first launched. Some good friends, folks here in the Raleigh area, at least Mark is. They took a seed round of funding, so good to see TriggerMesh continue. They are very focused around the serverless space and kind of interconnecting these new function-driven services and so forth, SaaS services. So congratulations to that team continuing to grow. So with that, we're going to wrap up Cloud News of the Week. A couple of acquisitions, a couple of new offering announcements, and some new funding announcements. So that's always fun. And this week, we're really going to dive into a topic that has been really kind of top of mind for a lot of you. Every time we talk about this topic, lots and lots of listens, at least from 2019. And so we're going to dive into what's going on with this hot topic in 2020 right after the break. Today's show is sponsored by MongoDB. As a programmer, you think in objects. With MongoDB, so does your database. MongoDB is the most popular document database built for modern application developers and the cloud era. Millions of developers use MongoDB today to power the world's most innovative products and services, from cryptocurrency to online gaming, IoT, and much more. Try MongoDB today with Atlas, the global cloud database service that runs on AWS, Azure, and Google Cloud. Configure, deploy, and connect to your database in just a few minutes. Check it out today at mongodb.com/atlas. That's mongodb.com/atlas. Today's Cloudcast is brought to you by Datadog, a scalable monitoring and analytics platform. In their latest report on container trends, Datadog analyzed 1.5 billion containers and found that in 97% of Kubernetes environments, container lifespan was under 30 days. To help you visualize and manage this dynamic infrastructure, Datadog seamlessly integrates with over 350 technologies, such as Kubernetes, Docker, Amazon ECS, and much more. Plus, with Datadog are container-specific features like the live container view and the container map. So try Datadog today for yourself with a free 14-day trial, and you'll receive a complimentary t-shirt. Just go to datadog.com/cloudcast. That's datadog.com/cloudcast. And we're back. And folks, one of the probably most common topics that we're seeing more and more as customer companies are trying to build new types of applications. We've seen certain standards kind of emerge. Obviously, we're seeing containers become more frequently used. We're seeing Kubernetes kind of become the standard. And then what happens is, what happens is we get into all these more complicated topics. How do I isolate traffic? How do I do security? How do I encrypt things? How do I monitor stuff? And this is really where this topic of service mesh comes in. So, Aaron, we started talking about service mesh a couple of years ago. We're still kind of trying to figure this stuff out.
Yeah, absolutely. And as part of that today, and, kind of always trying to bring guests in that are smarter than us, and this is certainly the case in this instance, as well as kind of friend of the network, if you will. First time on this show, but would like to welcome to the show Christian Posta, field CTO at Silo.io. Did I get that correct these days, Christian?
Solo.
Sorry.
Yeah. No silos.
and you've been on our other podcast, if you will, in the network, the PodCTL podcast. Tell us a little bit about your background, and you've been really active with application developers and distributed systems for quite some time.
Yeah. So I joined Solo a little over a year ago. And I did so because I saw that they were building really interesting solutions in the service mesh space. And that's an area that I had gotten into over the last few years. Before that, I would say I had worked at big enterprises, big banks, and so on. So I have an empathy for what real life is like outside of conferences and meetups and so on. But then I got really involved in open source at the Apache Software Foundation around mostly building message brokers. So ActiveMQ, and got involved poking around a little bit with Kafka. And then I went to work for an open source integration and messaging company called FuseSource back in 2012 that eventually got acquired into Red Hat and was a big part of building distributed systems and applications following some of the principles of the technologies that I had been involved with, and then helping to learn and others help the Red Hat customers adopt solutions around containers and Kubernetes, and then the things that go on top of it. So I definitely have a developer background with a strong interest in building these large-scale systems. They're able to withstand faults and be secure and large-scale and so on. And during my stint between FuseSource and Red Hat, I spent probably close to a year at Zappos.com, which was a subsidiary or is a subsidiary of Amazon. And at the time I was there, it was back in 2012, I believe, they were moving they were going cloud native. Zappos was going cloud native. They were going all in on Amazon and AWS, and those are two different things, and was at the time. And I got a lot of familiarity with the way Amazon works and their infrastructure, at least at the time, worked, and the way their teams interacted and so on. So I kind of have a view of what DevOps and microservices and all that stuff was before it kind of went more mainstream as it is right now, coupled with, I've worked at the large enterprises as well.
And a fantastic blog to boot. So everyone, do yourself a favor. If you don't already regularly go check it out. In the show notes, it will be the link to Christian's blog. It is definitely something worth checking out and learning a good bit from.
Yeah, I appreciate that. Thank you.
Yeah, one of the things, Christian and I have known each other for a few years now, and one of the things I always appreciate about your approach to things is, like you said, you really come at it from a developer's perspective. You're very good. You're one of the unique people in terms of you have the ability to talk about it in depth. You still get your hands dirty with it. I've seen you work with different companies, writing sample code for them, helping them do some stuff. You're a pretty prolific writer and stuff. One of the things I'm really kind of curious, and I'm looking for kind of a starting point. We're in 2020. We're talking about service meshes. And I think when we first started talking about service meshes, it was, we're trying to take some of the capabilities out of applications so they don't have to be so bogged down. We kind of want to put it into a platform. And now we've seen service mesh really kind of evolve. It touches a lot of things. It's, there's some networking elements to it, proxying and layer 4 through 7 routing. There's security elements of it for authentication. There are, in some cases, it sometimes looks like an API gateway. As somebody who spends a lot of time talking with different companies about service mesh, how do you tend to start the conversation? What's a good starting point, or maybe what's a starting point that's going to take someone down a bad rat hole?
I think I like to start off with the service mesh infrastructure is complicated. It's getting it in, getting all the right teams on board, operationalizing it. That today is complicated. Now, various service mesh implementations have improved usability and so on, but just in general, from an application developer standpoint, they see this obscure box sitting next to their application instance that's supposed to do all this wonderful magic to them. For the folks that are just tipping their toes into it, it's complicated. So I typically start off with let's identify where you are in the journey. And what I mean by that is, at the end of the day, we're adopting this maybe complicated technology to be able to build our applications and deliver features faster so that we can figure out what doesn't work, right? And then concept that does work. So that's the kind of the backdrop. So there are many, many other steps before adopting a service mesh that you would like to get into place. First of all, using a source control management system. Maybe getting and maturing to the point where you're able to do immutable infrastructure and deployments, and starting to adopt the automation to be able to do continuous delivery and starting to go down that path, right? So those are some of the low-hanging pieces of fruit that you can adopt to go faster. Now, we say service mesh is another layer that can help you go faster safely. And so there are things that it can afford so that you can go faster safely, but make sure you're in a position to adopt that first. Make sure you're in a position to start to see the value that the service mesh brings, instead of just saying, because we do run into, this is, not much I can do about it, but there are organizations that say, all right, we're doing canarying and chaos experimentation, and we're going to do this on containers and Kubernetes. And then I said, okay, well, where are you running Kubernetes? And they said, oh yeah, well, we don't have that up yet. We're still doing that. And in my mind, I'm thinking this is going to be a long, frightful journey. If it's fine, I guess, to have these targets, but unless you're feeling the pain, unless you're about to go down that path of experiencing that pain, you might be biting off too much too early. So there's definitely, the starting point is, do you need a service mesh?
That makes sense.
That's the long way of getting to that.
Yeah.
Christian, let me ask you this then too, because, it is a little bit of, okay, there's the technology building blocks, but let's step back even maybe a higher level and say, what are the most common use cases when a service mesh is being used effectively? And then maybe a flip side question to that, or what are some of the places where it's discussed or even, planning on implementing, but shouldn't be?
Mm-hmm. Right. So I guess the service mesh that we're talking about is kind of the incarnation that we see, at least in the open source, where we have a proxy that lives with the application instance. And in Kubernetes, you can think of that as a container in a pod along with the application, which is also in a container in the same pod. And when the application talks out to the network, or a piece of another service outside the network tries to talk into the application, that this traffic will always go through that proxy that lives with the application. And that proxy can do things like collect telemetry. It can secure the transport. It can implement retries and circuit breaking when communicating to outside services and so forth. So where we typically see the right scenarios or the right environment to adopt a service mesh is when, first of all, when you have a mix of different applications, languages, different application languages and frameworks. So one of the challenges of operationalizing a services infrastructure when you have a mix of a high, polyglot, the various languages that you're using, is to implement things like telemetry collection, circuit breaking, load balancing, service discovery. To implement these things consistently across all of the languages and all of the frameworks. So that's definitely step number one, where you have this polyglot environment. Now, you can bring a service mesh in to solve those problems in a consistent way because it lives out of process, because it lives out of the application. So it doesn't really matter what you've written the code in. So solving that problem, a service mesh does that very effectively. It reduces the operational overhead of running all of these services. The second thing is when you might be deploying applications into Kubernetes, for example, or I guess any cloud platform, but where you're taking and you're kind of lifting and shifting, and you have these services that you want to run, but you can't modify them to fit nicely into this new cloud platform world. When you go into a cloud or a cloud platform, you kind of have to build the application assuming and knowing that things will fail. Like the database will not be there at some point, and the network might not be there, and so on. In the past, we built our applications thinking, well, that'll never happen, right? At least not for us. And then when things do go sideways, then the application pays the price, everything's down, and all hell breaks loose. But so bringing things into this environment that weren't already built for that environment, the service mesh can help retrofit it, I guess you could say. So those are two big, and then there's also the tactical. Well, we gotta secure our services. We want to be able to write policy about which services are allowed to talk with which others. Going down into the different capabilities of the service mesh, and ultimately, what we want is an API that we can use to automate how we apply policy and how we implement security and how we do routing and that. So the service mesh provides that nice API and fits nicely with the rest of the automation story. But the core pain that you would feel and get value from are those handful of things.
Yeah. We've gone, I mentioned that we started talking about this a couple of years ago. We have seen certain aspects of sort of modern platforms and development kind of standardized, right? We used to have lots of container orchestrators. Now it's mostly Kubernetes, but we still see a lot of different implementations of service mesh, right? Sometimes it's Istio, sometimes it's Linkerd. We see some stuff that's just Envoy. AWS has an approach. Do you think we're gonna ever get to a point? Put on your kind of your crystal ball hat. Will we get to a point where there is sort of one standard, or is it a good thing that there's a lot of different implementations? What's you get to see a lot of them, especially because Solo works with a lot of them. What's your take on just sort of the fact that we still have so many different implementations? It's a good thing. We're still learning what works best. What's your take on that?
Yeah, I think it's a good thing right now. I think they will, the things will start to converge. Not that I think one will win, but the set will become smaller. But I think it is a good thing right now because since this is new, we're still relatively new. It's actually I'm starting to see a lot more deployments of it. So it's actually getting deployed now. But I think the technology and the use cases are, once they get into an enterprise environment where things are not as idealistic, we're starting to see what the different workflows might be, how people might adopt, for example, most of the service meshes can do mutual TLS between the services. Like how are they actually adopting that in their environments? And because there are different implementations with different ways of thinking. So for example, Istio is kind of we can do everything. And Linkerd is kind of we're going to pick these core features and do them really, really well. We're able to see, how the market reacts to that, right? They do crave. They don't want this super complicated, very difficult to set up and use technology. So I think it's fine that everybody, Linkerd and Consul and App Mesh and the Trafic folks and Istio and so on. I think it's good. It gives variety. Unfortunately, it gives confusion, but it gives variety and with various different viewpoints that we'll see what ends up working. I personally, maybe it's a selection bias thing, but I personally end up seeing a lot of the Istio deployments. So in my mind, I'm thinking Istio is doing pretty well, but I know Linkerd is doing well too.
Yeah, and one quick sort of follow up, I guess, there's this thing that emerged over the last year called SMI. What is the service mesh interface? What is that, or what's its intention to do?
The SMI is intended to be kind of a more simplified and higher level API that describes service mesh functionality in a implementation neutral way. So it was kind of at Solo, we had this idea back in November 2018. We launched an open source project called Superglue, which we were going to build, basically focus on this, simplifying the APIs at a higher level than each individual provider, and allow you to write configuration and policy and so forth, agnostic of the underlying mesh. But then we saw, we partnered with Hashi and Buoyant and Microsoft in May of 2019 to launch the SMI spec, which was it is an open source, community driven way of defining and continuing to fill out what that spec looks like. So it's intended to be mesh independent, but focus on at a little bit higher level the core use cases that a mesh, the problems that it solves, like routing, telemetry collection, policy, defining policies, and so forth.
Okay, very cool. Yeah, so I think that's helpful. It gives different people that are considering meshes some sense of okay, no matter which one I pick, at some point, there is a contingent of companies that are working on some interoperability. There's going to be some commonality. So, like you said, whether or not we ever get to one, choice can be good. There's also this parallel thing to try and build some consistency, some interoperability. I think that's it should make you feel good if you're out there looking at meshes. You're trying to evaluate them. That there's some different options that are going to help you. Whichever one you end up picking.
There's definitely that effort, but I want to come back and just say that the choice now is good because ultimately the users and the consumers of the meshes are going to help pick which ones kind of filter themselves out. Yeah. I do think that each public cloud is going to have their own service mesh.
Yep.
So I don't think that Amazon, Google, Microsoft, Alibaba, others are going to say, hey, let's just use X. I think they're going to, and we're seeing it, they're going to have their own mesh implementation. And so from that standpoint, there isn't going to be full convergence. For the prepackaged or self or manage it, run it yourself, I think we will fiddle it down or filter it down. I think it's too early to say which one that's going to be, but at the end of the day, there will be multiple mesh implementations.
Yeah, I know you write pretty frequently. You wrote a great post today about kind of the intersection of things like service meshes and API gateways. As you're thinking about the types of challenges you see with different companies trying to do implementations where we need stuff, what are some of the things in 2020 that you're really keen to figure out, or you think we'll see some advancement, potentially happening in this space, whether it is, kind of the mesh directly or kind of the things maybe that are around the mesh, could be an API gateway, it could be some other technology.
Yeah, so there's definitely some forward-looking things in the service mesh ecosystem, but and we'll talk about that. But I think for those folks that are just trying to get their head around a service mesh, my suggestion always is, it's still true today as it was over the last few years, that if you're going to go down the path of a service mesh, learn and understand the proxy technology that the particular mesh has chosen. Now, in a lot of cases, not all, but a lot of cases, Envoy proxy from CNCF has become the underlying technology. Now, Linkerd does not use Envoy. The Containus or the Mesh folks from Trafic, they don't use Envoy, and there's others, but for the most part, or AWS, Istio, Consul, Kong. So these mesh technologies are being built on top of Envoy. But I guess the point is, learn and understand how to operate, how to debug these proxy technologies. Otherwise, once you go to a mesh where you have maybe lots of different applications scaled out across lots of different pieces of infrastructure, and you have lots of these different proxies running, you're not going to be able to reason about them and be able to debug them when things go wrong if you don't understand it, if you don't understand the underlying technology. So I always say, if you're going to adopt these technologies, adopt a service mesh, start with one proxy and get your head wrapped around that. At Solo, we built an API gateway called Glue that is built on top of Envoy and helps you just focus on, like, this is Envoy. I'm running one Envoy, or at the edge, I'm going to run Envoy. I'm going to learn how to operationalize it. I'm going to learn how to debug it. I'm going to learn how to upgrade it and configure it, and so on, right? These crawl, walk, run type approaches. And then from there, we can bridge out into a service mesh. Maybe we might want to pick one particular application that is well suited for this and introduce the proxies there, and then start to grow out from there. I think that is something where you start to adopt a service mesh and you say, well, all of these service instances need to have a service proxy, and then you find yourself washed in service proxies. And when things start to go sideways, you didn't get the first principles in place first.
Yeah, no, makes a lot of sense. Let me ask you one last question. You talked about learning the proxy technology. Makes a lot of sense. We always, recommend people learn the basics, understand your fundamentals. The way that the infrastructure team probably thinks about service mesh or even proxy is going to be somewhat different than what the developer does. Do you find that you see those groups kind of pairing up and trying to learn this, or do they learn it in different ways? I mean, from their perspective, what have you seen, in talking to developers, how they might interact with a mesh versus how an infrastructure team might interact with the mesh, and how much variance do you see in that?
Yeah, so the way the developers, and I'm pretty interested in this part, the way the developers so far interact with the mesh is through either the mesh's API or maybe even less likely, the API that platform team builds on top of the mesh. So we know that the various service meshes have very differing ways of defining configuration and the various settings for timeouts, retries, circuit breaking, load balancing, routing, and so on. But the way the developer sees that, they might not care about all of the knobs and switches that you can configure. You might just care about what does the context path look like for the service that I'm exposing, and how do I get traffic to that? Or when services are calling my service, what should be a basic timeout baseline for timeouts when calling my service, or retries or whatever. So those, or circuit breaking. So those are the types of things that developers would care about, and they probably wouldn't care as much about what the exact virtual service and matching query matching parameters to use in the configuration. They'll probably just see whatever the platform team exposes to them as, well, in this settings file or this JSON file or this properties file, just add circuit breaking on, or timeouts equals 50 seconds or milliseconds, or whatever the unit is. From an operator's standpoint, this is going to be part of their infrastructure. This is going to be just like it is Kubernetes if you're running that, right? So you need to understand the proxy technology inside and out, not just the APIs that it exposes or that you expose to the developers. And I think that what's interesting is that it won't just be, I think going forward, it won't just be proxies. So that's another part of this discussion. I gave a talk at the Service Mesh Con at KubeCon in North America in 2019 on kind of the continuum of what would make up the service mesh data plane. And proxies are sort of well known right now, but there's also room for these types, certain types of the mesh functionality to be implemented inside developer code. So if you have an optimization that you need, or you have one or two particular services that are very sensitive to latency and overhead or whatever it is, you might write some of this stuff directly inside of the application. But the service mesh control plane could still configure it using the same set of APIs and so on. We see things like, it's in the CNCF, it's called the Universal Data Plane API. There's an API that can be implemented by proxies, could also be implemented by libraries or frameworks. For example, gRPC is starting to go down this path. Others could as well. It could be implemented by gateways, shared gateways. So this universal data plane API is kind of a hint that the service mesh data plane today might be made up of proxies, but there's going to be optimizations, and there's going to be areas where it makes sense to use different technology to implement the data plane.
Yeah, no, it's it does. It comes back to the original thing you said. Service meshes are potentially complicated. They're there to solve sort of a complicated problem. Distributed systems are a complicated problem, and we continue to see them evolve as we learn a little bit about them. New options come along, and it is good to see it continue to progress. And then it is something that we need to continue to kind of keep an eye on, because it's a space that touches a lot of people, whether it's developers or ops. Christian, you are are out and visible quite a bit. I know you speak at a lot of events, whether they are O'Reilly events or community events. You're writing quite a bit. If people want to reach out to you and kind of engage around some of these topics, what's either the best place to do that, or maybe some places you're going to be in the next couple of months?
Yeah, that's and I love interacting with people, whether that's out in the community, whether that's prospects at Solo or customers, because I like being grounded in reality. You all working in enterprises and your various companies, you have to, it's real, right? It's not just what you see or with the new technology that's coming out. And although that's exciting, so I definitely would appreciate that folks feel free to reach out to me. The best place is by Twitter. I'm at Christian Posta, Posta, and I'm absolutely happy to discuss anything related to what I'm working on or what you're working on. I will be, I'll be at a meetup in Atlanta, January 29th. I believe that's a Wednesday. I will be in February. I'll be at the O'Reilly Software Architecture Conference in New York. I will be at QCon London 2 weeks after that. And then probably other ones that I don't have at top of mind right now. But yeah. Twitter is probably the best.
Yeah, very, very cool. And I highly recommend it if you do get a chance to run into Christian. Like he's mentioned, loves interacting with people. I've seen him do it dozens of times. So Christian, thank you so much for the time. Field CTO at Solo, doing really interesting things over there with Edith and that crew. And Christian, again, thank you for the time. Appreciate the explanation. And folks, with that, thank you as always for listening. Thanks for telling a friend. Thanks for reviewing the show on iTunes and other places. And we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.